My name's Craig Sexton, one of the co-owners of SNX Technologies. We're a Minnesota-based company that manufactures contour edgebanders. We're very excited to be part of this virtual event held by Hexagon. What we'd like to show you today is not only the differences between our System 1 and System 2, but also give you an insight of our factory and how these machines are manufactured. What we're going to do today is just show you quickly how easy the machine operates. From an operator standpoint, we're just going to simply put the part in, step on the foot pedal, and get the machine rolling. And from here, the machine pretty much takes care of itself. Now, one of the key features on this machine and how we're able to get a nice tight butt joint is we have a laser. And what that laser does, it actually reads this leading edge. And then after it reads the leading edge, it's actually going to set an encoder off and it's going to do counts. And if your joint is off for some reason, it's very simple to adjust that joint by simply pushing a button here. As I mentioned, your laser on setting is just an offset, and that offset can be easily adjusted by 1/10 of a millimeter. And what that's doing is it's telling the encoder, after this laser reads the leading edge, the encoder will count to 63.9 millimeters and make a cut. Now, if that joint is not perfect, again, you can just adjust that by 1/10 of a millimeter, which is only 4/1000ths of an inch. Now that we've set our offset for this joint on a straight, we can then go and store it inside the machine. And once that's stored inside the machine, we can switch parts to a totally different geometry. And as long as we're joining on a straight, the offset's going to be identical. All we need to do is hit 2 PLC, and those offsets will automatically go into your auto screen. And then regardless of the shape, as long as you're joining on a straight, they're going to be identical. So let's go ahead and run this part. As you can see, with a completely different geometry than the rectangle, because we're jointing on a straight, you get the exact same results. So far, we showed you how to fine-tune a butt joint. So now we're going to go from a butt joint to an open-ended part. So the only two things you need to do on the machine is, one, push the laser out of the way, and two, turn the laser from on to off, and then you're ready to go. So, not even knowing how long this is to edgeband, we literally just turn the vacuum on, step on the foot pedal, wait for the banding to come out, follow the leading edge, step on the foot pedal again towards the end, and without knowing the length, you have a perfect part already. So let's try a different part. So let's do another part for you guys. This part you're probably a little bit more familiar with. It's the corner shelf of a closet. And the thing about this part is we're doing an extremely tight radius. This is 3/4 of an inch. That right there is pretty much as tight as we can go. But again, on this one, I don't know the length of it. Doesn't matter. Make sure your laser's off, your laser's back out of the way. Put on your vacuum. Step on the foot pedal. Wait for the leading edge to come in. Follow it. Now once we're done banding this, and we know the length of it because the end coder counted at 650 millimeters, all we need to do is enter in 650 millimeters, and the next time we do this part, we just have to step on the foot pedal once. It'll know automatically when to cut it off. So the demonstrations we've been doing so far have been on a twin arm machine. And one of the big advantages a twin arm machine has is why an operator's over here banding a part, another operator can be on the other side of the machine trimming a part. So the throughput literally is about 80% more than a single arm machine. Having said that, the working units, the controller, and the trimming unit are identical on the twin arm machine as they are in the single arm machine. So on a twin arm machine, an operator would bring a part over to here, step on the foot pedal, it'd lift off, and then while he's going to be trimming that part, an operator over here can be putting another part on, does not have to be the same, and can start banding a part over here.
Hello, Mike Nolting, co-owner of SNX Technologies. Craig has already spoken to you with regards to the banding cell. I now would like to talk to you about the trimming cells. We've got two different options here. We've got the manual adjustments with digital readouts, but we also have a full CNC servo-driven system. With that servo system, your operator only needs to type in the banding thickness, the board thickness, and then everything else is set up automatically. So what I'd like to do is show you how we actually operate the trim cell. Open up our heads, put the part in. I check the cut quality. I'm a little bit high, so what I'll do here is I will just adjust digitals. They are actually factoring down to 1/10,000th of an inch. I've now achieved the cut quality that I like. I can come in here, zero out my digital readouts. At that point, it has 0, 0, 0. I know now whenever I'm doing 3/4 board, 1 millimeter banding, I continue to go back to that number. Now I'm on our single arm machine. With this machine, the same operator bands the part and then brings it over to the trim station. What we've got on this machine also is our servo setup, where the operator types in board thickness, banding thickness, hits calculate, move, and then everything is set up automatically. At this point, the operator is ready to start trimming. There is no need for any manual adjustments at all. I'd like to introduce to you what we call the little pucker. It is a hand scraper to remove that last little bit of glue and edge on the top of your boards.